Okay, moving on to double and half angle formulas today. If you look, here's the half angle formulas. They should be at the top of your notes. You also have them on your master formula sheet. As you can see, they don't look quite so pretty, but they'll be okay. And then here's the double angle formulas. Notice that there are 3 formulas for cosine at 2 theta, and any one of them are fine and interchangeable, so you can pick when it comes that time. All right, here's the first problem that we're going to do. So the book or me or whoever is going to give you some information at the top that's in the green box up there. What I'm telling you here is that sine at some angle theta is positive 3/5. And I'm telling you that the angle theta is somewhere between 0 and pi. And it's important to remember where that is. We know that here is 0 and here's pi over 2. I think I said pi before. But it's between 0 and pi over 2. And I'm getting that from this little piece of information right up here. So theta is somewhere in quadrant 1 up there. So when we make our triangle, our little triangle is going to look like this. Okay, here's my theta. Sine is 3/5. We know that sine is the opposite or the y value over the hypotenuse or over the hypotenuse or the r, the radius. Okay, so either way you want to think about that. But this is 3, this is 5. I can do x squared plus y squared equals r squared. So 3 squared plus x squared equals 5 squared. So x squared will be 16. So x will be either positive or negative 4, and you're going to need to decide, and that's why the quadrant is important. When you're in quadrant 1, your x values will be positive. So my x will be positive 4. Okay? So I'm going to fill out the little blue box here. So my x is 4, my y is 3, and my r, or my hypotenuse, is 5. Okay? So now, in part A here, I'm asking you to find cosine at 2 theta. What some people get tempted to do is to take cosine at theta and multiply your answer by 2. And that is not what I want you to do here. If that's what I wanted you to do, I would write it like that. Okay? But I didn't. I wrote it as cosine 2 theta. When that happens, what you need to do is you need to use your formulas, okay? So you're going to go over here and you have cosine 2 theta. You can use any one of these 3 formulas. It doesn't matter. Either one, any of them are going to be just fine. I like to choose this one just because it kind of usually takes care of some things and you don't have to get common denominators and simplify and all that good stuff. So I'm going to choose that one, but you can choose any of them. So the formula for cosine 2 theta is cosine squared theta minus sine squared theta. And then you're going to use this information here in this kind of blue colored box to fill that in, okay? So at that angle, my cosine is my adjacent over my hypotenuse. So adjacent is 4 over 5. And then, of course, I need to square that. My sine is my opposite over my hypotenuse. So my sine would be 3 over 5. And, of course, I need to square it. And 4/5 squared, square the top, square the bottom. You get 16/25. And 3/5 squared, again, square the top, square the bottom. And then 16/25 minus 9/25, of course, is 7/25. And that's your answer for that one. Okay, same information, you guys. What I've given you at the top in the green box has not changed. And, of course, we already calculated what's in the blue box, so I don't need to recalculate that. This time I want you to find sine at 2 theta. Again, you can't find sine at theta and multiply your answer by 2. That's not what I'm asking you for here. I'm asking you to find sine at 2 theta, which means you need to follow this handy-dandy little formula right here. So the formula for sine at 2 theta is 2 sine theta cosine theta. Okay, and again, using the information in the blue box, sine is opposite over hypotenuse, so sine is 3 over 5. Cosine is adjacent over hypotenuse, or 4 over 5. When you're multiplying fractions, you do not need common denominators, and I'm multiplying here, so think of this as 2 over 1. If you multiply all the way across the top, 2 times 3 times 4 is 24. And all the way across the bottom, 1 times 5 is 25. And that should do that. Okay, moving on. Again, same given information. This is just part C here. So nothing in the green box or the blue box has changed. Now I'm asking you to find sine at theta over 2. And again, you can't find sine at theta and cut your answer in half. If that's what I wanted you to do, I would have the line go all the way across like this, but it doesn't. So you are going to need to follow the formulas. So the formula for sine at theta over 2 right here is plus or minus the square root of 1 minus cosine theta over 2. So this is not as fun. Plus or minus the square root of 1 minus cosine theta over 2. Okay, so here we go. I'm going to ignore this plus or minus at the beginning for just a minute, and I'll talk about it at the end. You do need to deal with that, but I will talk about it at the end, so just hang tight, okay? So into this formula, you're going to plug the information again from the blue box, okay? So I'm asking you to plug in cosine at theta, and again, cosine is adjacent over hypotenuse. So your adjacent up there in the blue box is 4, and your hypotenuse is 5. So I have 1 minus 4/5 all over 2. Okay, you need to simplify this, which is not so pretty, but we can do this. Of course, right now, this 1 that's up here is 1 over 1. So I am going to need to get common denominators and make that be 5 over 5 right there. Okay, so now I have the square root of, right here, 5 minus 4 over 5 all over 2. Okay. Well, clearly, 5 minus 4 is 1 over 5 over 2. And think of this as 2 over 1 right here. And so instead of dividing by that 2, I can multiply by the reciprocal, and the reciprocal to 2 over 1, of course, is 1/2. So now I have plus or minus the square root of 1/10. And you're going to be tempted to leave it here, you guys, but you have to keep going, okay? The square root of 1/10 is really the square root of 1 over the square root of 10, which is fabulous, but you can't leave a radical in the denominator. So I am going to multiply by root 10, and then I will have the square root of 10 over root 10 times root 10, which is root 100, which of course is 10. Okay, so here's my answer, except for I have to deal with the positive negative piece of it, which is actually the trickiest part. Okay, so here's what you need to think about. I am asking you, of course, from the beginning, and I didn't keep carrying this down, but I am asking you to figure out sine at theta over 2, or sine at half of theta. Okay, so now I want you to think back a couple screens ago when we were at the beginning. I told you that theta up here was between 0 and pi. So that's where theta is. Not half of theta, but that's where theta is, okay? My goal in this problem over here is to figure out where sine at theta over 2 is. I need to figure out where if sine at theta over 2 is either positive or negative, okay? So again, at the beginning, at the very top, in the green box up there, in my green box, I had told you that theta was between 0 and pi over 2. Well, to determine this, I need to know not where theta is, but where theta at pi over, or where half of theta is, okay? That's what I need to know. I need to know not where theta is, but where half of theta is, okay? So I am going to cut this in half, and then I have half of 0 is still 0. Obviously, this is where theta over 2 is. Half of pi over 2 would be pi over 4, okay? So what you know then is if theta is between 0 and pi over 2, half of theta is between 0 and pi over 4. So half of theta will be somewhere in this region right here, okay? And my sine values, or my y values in that spot on my unit circle, are always going to be positive. So I know that this is a positive angle right here. Okay, and that's going to be my answer. Okay, and we are going to skip the cosine one right now, and we're going to come back to some more of those positives and negatives. I know you're going to need them, and we'll hit another one, okay? So here's your next one. Cotangent at theta is -2, and secant at theta is less than 0. In other words, secant is negative. That's what this is telling you right here, that secant is negative. Okay? And here clearly you can tell, since -2 is a negative number, you also know that cotangent is negative. Okay? So you need to use your unit circle and you need to find the one quadrant where both cotangent and secant are on the negative list, because cotangent is negative and secant is negative. And the one quadrant that that happens at, that cotangent is negative and that secant is negative, should be in quadrant 2. Okay, so when you think about this, you're in quadrant 2. Quadrant 2 is between pi over 2 and pi. So I'm going to just kind of write ourselves a little note so that when we come back to this, we know what we're doing. Okay, so cotangent and secant are both negative in quadrant 2. So because I know that theta is between pi over 2 and pi somewhere. That's what quadrant 2 is. It's between pi over 2 and pi. Okay, so now I'm going to draw my handy dandy little triangle right here. Okay, secant is negative. Obviously my x value is negative here. So this distance right here, because it describes position, is negative. This side of the triangle right here is going to be positive. Okay, so when you think about this, cotangent is adjacent over opposite. Adjacent, wow, I can't write, over opposite. Okay, the 1 is down here, so you need to think, does that negative go with the 2 or does the negative go with the 1? And because you're in quadrant 2, your x has to be the one that's negative, or your adjacent has to be the one that's negative, and your opposite, or your y, because you're moving up, has to be the one that's positive. Okay? Then, obviously, to find the hypotenuse, you're going to go x squared plus y squared equals r squared. So 1 squared plus negative 2 squared equals my radius squared. So I would have 5 equals my radius squared. So my radius is technically either positive or negative 5, but your radius can never be negative. So we know that this is root 5 right here. Okay? So your x or your adjacent is negative 2. Your y or your opposite is 1, and your hypotenuse or your r is root 5. Okay, so I need to find sine at 2 theta. Again, you can't multiply sine at theta, find sine at theta and multiply it by 2. You have to use this formula right here. So I'm going to use 2 sine theta cosine theta. And then I'm going to use the information in the blue box. Sine is opposite over hypotenuse. Now I never want you to plug in a quantity that has a square root symbol in the denominator. So I don't really want you to plug in 1 times root 5. Okay, when you plug it in, I want it simplified. So 1 over root 5, can't leave a radical in the denominator, so I multiply by root 5, and I will get root 5 over 5. That's the quantity that I want you to plug in. Okay. All right, and then cosine is adjacent over hypotenuse, so negative 2 over root 5. Again, can't leave a radical in the denominator, so I'll get negative 2 root 5 over 5. Okay, and think of this as 2 over 1. Again, when you're multiplying fractions, you do not need common denominators. You can just multiply across the top. So across here, 2 times negative 2 is negative 4, and then root 5 times root 5 is 5. So negative 4 times 5 would be negative 20. And then down on the bottom, 1 times 5 times 5 is 25. And of course that will reduce to negative 4/5. Okay? All right, and one more, again, what's in this little box at the top has not changed. So this is the same problem. Now I'm going to ask you to find sine at theta over 2. And so, again, I can't find sine at theta and cut my answer in half. I need to use this handy dandy little formula right here. Okay, so I'm using that formula. And it will be plus or minus the square root of 1 minus cosine at theta all over 2. Okay, so cosine is adjacent over hypotenuse, or x over r is another way to think about that. So again, when you plug that in, I don't want you to plug it in with a radical in the denominator. If you remember from the last screen, I had -2 over root 5 for cosine. Get the radical out of the denominator, and you will get -2 root 5 over 5. Okay, so that's what I want you to plug in, -2 root 5 over 5. Okay, so clearly the negative times the negative will become a positive. Right now, this is 1 over 1. You need to get a common denominator first before you worry about flipping them. I'm going to change the 1 over 1 to 5 over 5. So then I will have this, 5 plus 2 root 5 all over 2. 5 plus 2 root 5 over 5 over 2. Okay. And then instead of dividing by 2 down here, you can multiply by its reciprocal, which is 1/2. And so then I will have this. Okay. Now, here's the good news. Technically what this is, you guys, is this. 5 plus 2 root 5 all over root 10. And then what would happen is we'd have to conjugate this, and we're ending up with more radicals within radicals, and it's ugly and it's gross and it's icky. So the good news is this. Once you get to a point where you have a radical within a radical like this, a radical right here, within a radical, even if it's a fraction, you can leave it. You don't have to simplify this. Then some people go, well, I can reduce 5 and 10, and I can reduce 2 and 10. And you're right. But 5, 2, and 10 are not all three divisible by the same number. So you really can't reduce the 5 and the 2 and the 10, because 5 over 10 reduces a different way than 2 over 10 would. Okay? So the only thing that's left here is to decide whether this is positive or negative or not. Okay? Positive or negative, not. Positive or negative. So again, you guys, what I'm asking you to find in this problem, if you remember, and it's been a while since we've seen it, but I'm asking you to find sine at theta over 2. Okay? From a couple screens ago, we figured out that theta itself was between pi over 2 and pi. Okay? Theta was between pi over 2 and pi. But I'm not asking you to find where theta is here. I am asking you to find where theta over 2 is. Okay? Where theta over 2 is. So, if theta is between pi over 2 and pi, then theta over 2 is going to be half of those. So half of pi over 2 is pi over 4, and half of pi is pi over 2. So if I think about this on my unit circle, here's where pi over 2 is, and here's where pi over 4 is. So it's going to be somewhere between pi over 2 and pi over 4. And my sine values, or my up-down values, or my y values in that spot are going to be positive. Okay, they will be positive in that spot. So there is my grand final answer. All right, and then here is your homework for tonight, and hopefully this will go okay.